nice, easy, excellent, Trisbian. And then the second question is looking at expanding something to the power 5. Well, it's a non-calc paper, but why do you think that they asked you to do this up here? So you could use your Pascal triangle numbers, yes?
Sorry.
So we do as we do normally. So they want to know that the value of stop turning it over. X cubed. So they want to know the x cubed portion. So we write our general formula. So it's 5r and 2x all to the power 5 minus r. Some of you are still forgetting your brackets. I wish to hunt you down. And then 3 to the power r. Yes, so that's our general formula. Trisbians. Now, we then say, okay, which of these terms here has got an x in it? Just this one. Yes? So this is all that we're interested in being 3. So we know that 5 minus r has to be 3, which means r is 2. Trisbians. So we now know we're finding 5, 2, 2x all to the power 3, 3 to the power 2. Yes? Lovely. Now, 5, 2. Some of you are like, oh, I don't know what that is. Well, look, we've got this up here, you nanas. Yes?
Oh my God.
So this is 5, 0, 5, 1, 5, 2. Ah, lo and behold, that value is 10. Yes? So that's why I wanted to draw out and remind you that A and B parts are often connected. There's a reason that they do that. Again, I'm harping on about the brackets because that's another thing that people make mistakes with. This is 2 to the power 3 as well. It's not just the x cubed. Okay? It's 2 to the power 3, so you've got your value of 8. And then obviously you've got your x cubed. And then 3 squared is not 6. Some people thought it was. It's secretly 9. And then 10 multiplied by 8 multiplied by 9. You're supposed to be able to do that in your head. Hopefully you can. Do the 8 times 9 first maybe, and then multiply by 10. So you get the 720. Okay? Now, it was harsh. Because it does say specifically in the notes, do not award marks if... No, shut up. Do not award final A1 for final answer of 720 if 720x cubed is seen previously. Shut up, that's not the one I was talking about. There was one later on where it asked for the coefficient. Oh, that's it. It was number 4. It says, ask for the coefficient of x to the 5, and it says, do not award the final A1 that if it has the x in it. Oh, yeah. So if you wrote negative 2463343, or whatever it was, x to the 5, you didn't get that final mark, which was really harsh, I thought, but I was following the mark scheme, okay? Because they just, for A, it just, because it asked for the coefficient. So if you put the term, so if you had the x to the 5 with it, it means that you didn't understand what coefficient meant. That's what they're getting at, okay? So it is harsh, and I'm sorry, because some people got a mark, the method mark, even though they didn't get the complete final answer, which was harsh. If you got all of that, but you just put x to the 5. Right, so this was the point I wanted to make. So I was talking about brackets. Now, number 3 is challenging. We'll talk about that in a second. So now we're going on to the non-calc bit. And it was your calculated paper, so you could use your calculator at this stage. So some people are still using the factorial formula. I wasn't sure why. I don't think there are any really general points that I need to talk about. I mean, most of them were just individual ones.
Or 6.
Oh, yeah. 5. I'm sure. 6 and 5.
And 6.
I was really surprised about that one. That took me like solid like 5.
Oh,
Like 10 minutes.
I didn't know what to do, and then I got to the end, and I was like, what?
Right, okay, so we've got 2x plus k over x to the 9. Okay? We up on this. And the coefficient of x cubed, so x cubed is the same as x to the 5. Okay, that's just my little notes to the side. Right, okay. First things first, let's rewrite this, because I can see I've got an x on the bottom. We don't like x's on the bottom. And this is where many of you made a mistake. You didn't rewrite this properly. What should this be when it's rewritten? Yeah, so this is 2x plus kx to the minus 1. Okay? Done?
Yeah.
So we first of all we need to find the x cubed term. Okay? So let's write our general thing. So it's 9r. All of 2x is to the power 9 minus r. And then all of kx to the minus 1 is to the power r. Yes? Easy peasy. And then we say to ourselves, right, okay, which term has an x in it? Both do, okay? So this time we're interested in both of them. So we now need to focus on both. So if we were to expand this bit, it would just be 9 minus r, yes? But then we've also got this bad boy here. So we've got minus r. You with me?
Mm-hmm.
So 9 minus 2r is our expression for our power. So we want to know, first of all, when it's a cubed. So we want to know when 9 minus 2r is 3. So that's going to be 9 minus 3 equals 2r. So that's when r is 3. That's our first time. And then when x is 5 as well. So we want to know when 9 minus 2r is 5. Oh my gosh, I struggle with that just then. And then so we want to know when r is 2. Okay? So we're going to stick those both in. So we've got 9, 3 to x to the power of 6. Kx to the negative r. No, what was it? Negative 1, this one. Kx to the negative 1 of 3. And then we're also going to do 9, 2 to x to the 7. Kx minus 1, 2. Yes? So now let's focus on the actual coefficient. So what's the value of 9, 3? Remember, we've got to count for this bit. 84?
Mm-hmm.
So where's that? Underneath it. So this is 84. And then here, remember, we've got a bracket around it because we always write brackets around it because otherwise Miss Harrison gets really frustrated and we make Harrison 6. So here, then we've got 2 to the power 6. So what's 2 to the power 6?
Oh.
What? No, wait, 2 to the power 6.
Yes, because we've got 2x all to the power of 6.
64?
That sounds right.
I think it's a 64.
What is
I don't know how much now. 2 to 3 is 8. 2 to the 4 is 16. 2 is 64. Katie's right. And then we've got here k to the power 3. Yes? Now, I'm only interested in my coefficient because that's what they told me was the same. I don't care about my x term. I'm just looking at the coefficients. Yes? And k is one of my is part of my coefficient. Then I'm going to do a similar thing here. So 9, 2. What's the value of 9, 2?
it is 36.
Is it? Thanks. And here we've got 2 to the 7, so that must be 128. because I knew 2 to the 6 was 64 up there for thinking, down there for dancing. And then this is going to be k squared, yeah? And what did they say about those two numbers? They're equal to each other, yes? So I've got 84 multiplied by 64k cubed is equal to 36 multiplied by 128k squared. I need to find k, so what am I going to do? Divide, yeah. Divide both sides by k squared, yes? Yeah. So if I do divide by k squared, that goes, and this just becomes k. And that means k is going to be 36 times 128 over 84, 64. And then what does it end up being?
607. Harrison, you still slapped me when you saw this.
I did.
Daft errors.
Yes, like, and when I reviewed it, I was like, this has to be right.
But that's what happens under test conditions. It all goes a little bit out the window. People get a bit nervous and make silly mistakes. But that's, and the tricky thing is, I mean, it wasn't a short test. I mean, I gave you the correct amount of time at the end. But you do have to be careful when you're looking at some of these, and if you're getting weird things. Now, 6 over 7 is not a normal number. I would probably get that answer and think, oh, I've probably done something wrong. But I would come back later to check that. But I don't know how to give you tips. I mean, the brackets is a big thing that people are forgetting about. And I was getting a bit frustrated. Keep writing brackets and keep drawing them in, because it does make a big difference when it comes to doing that. And what was the other one you wanted me to go through?
6. I had no
What's that about? Oh, you lot. These old rascals.
No, Harrison?
I'm going to move, I'm going to the next page, yeah?
Mm-hmm.
Right. Now, I feel like kind of saying put your hands up for this question. But I won't. Well, I was going to say, who did this? And get you to all say, can I just multiply both of these two things by this?
That's what I'm saying.
So, anyone who was thinking, no, you can't possibly do that because that would be incorrect. Why is it incorrect? Why do we need to tell Tamia that she cannot just do that? No?
Because you have to explain.
Why? But just mathematically, we always follow what? Business. Okay? The E or the I, whichever letter you use, or the O, what does that always stand for? Exponent. So we have to deal with this bad boy first,
Brackets.
which is around the brackets, before we do our multiplication. Yes?
But you can see where it gets confusing, because E is for brackets, so you want to get rid of, like...
So the bracket is here with this next to it. So that's
Right,
the
but
thing.
this
This is multiplied. There's no bracket here.
But it's a bracket next to it, so you can see, like...
We had this.
I would probably...
Okay, then not do that. Okay? This too has to be done after you've expanded this baby. Okay? It's against the law. The police will be after you. So I think that was a big issue with most people. In fact, I'm saying that, and then I like to have a go at it again. Okay, so think about what you would do. So you would expand this out just the same way as we've just done. And then you think to yourself, right, once I've expanded that, I'm then going to multiply it by this term here. Okay? So once I've got my expansion, so I'm going to do, I'm just doing it, aren't I? I'm just doing it.
And then like you expand
I've got 0,
and then
0. So that's my general formula for my expansion.
you
Yes?
don't get like that with this term.
I don't think so, no.
So then you expand this.
Well, maybe. Maybe should have given you one. Well, then you can put it upwards. Okay. Did you actually write that though, Stella? No, did you write 2ax cubed to the power? Did you have these values in there first?
What?
Did you do this bit, the expansion first? Did you do what we were just talking about that you're not allowed to do?
I did it both times. Because I'm confused. Look at this stuff that's in these square things.
Alright.
Yeah, she has it written down.
Does she?
Yeah.
Then maybe yes. Well, maybe if you had several different things, I'd probably got confused.
Wait, Gigi did the same thing I did.
How did you get 5?
I just chucked in a number. Because it was.
Oh, wait, anyway, we're too busy videoing. So this is our general expansion of this bad boy, okay? And they want to know the term, oh no, they told us the term for x to the power 5, yes?
Yeah.
So normal thing we do is we say, right, we're going to look at this and say which has got the x in it, or it's just this one. So normally we would say, okay, we want r to be 5.
That's
Okay,
right.
that's 3.
But why are we not going to do that this time?
Because you have x to be 3.
Because we're multiplying these things by this term as well.
So it has to be
Okay.
2.
So now what we're wanting to find,
Oh, 3 plus 2.
because
yeah.
if we need a term that has an x to the power 5, and we're multiplying each of these things by x to the power 3, then the way of getting an x to the power 5 is when this value is 2. Because we add our powers.
I would never have gotten that this lesson.
I'm sorry.
That's
Do
crazy.
you understand it though? The thing is, okay, it's a little bit like we've worked in an opposite way. You know how the question 2, it was expand it and then hence find the x squared term. Like you had your expansion and you knew to find x squared that you had to choose a different value for x. No, shut up. Is there anyone still sitting there going, oh my god, I'm still low? We're good now? It's all because we were multiplying this expansion by this term. Okay? So rather than having R5, we've got R2. So then you're going to do 11, 2, and 2 to the power 9, and then we've got AX to the power 2, all to the power 2. Right, so that's that, and then we're multiplying this bad boy. Oh no, maybe we should write out what these numbers are. What is 11, 2? Do we know?
55.
And what do we know what 2 to the 9 is?
5, 12.
And then that's a squared, x squared, yeah? And then perhaps we find out what this big number is.
62816.
How much be? Okay, so we've got that as that term, yes? Then what we're doing is we're multiplying that bad boy by ax cubed. So we've now got ax cubed multiplied by 28160 a squared x squared. And we know that that's equal to what?
1180.
Yeah? So essentially we can ignore, so we know that x cubed multiplied by x squared gives us the x5. So let's x name them out. And then we've got a multiplied by this, which gives me 28160a cubed. So a cubed.
Wait.
I'm waiting.
Never mind.
And then you cube root. I don't know. And you get something. 1.5 was it? No. 304.
3.
Wait, so what?
880.
Come from the question.
Wow.
Yeah.
Are we ready?
Yes.
Just rather not get marked than last time again.
I was just seeing where everybody else got their 1 mark too.
I tried to be generous.
Yeah.
Right, okay, so we've got this to the power n. So let's do our normal, so our general rule is we write that general thing first, yes?
Mm-hmm.
So we would have n r, 3x to the power n minus r, 1 to the power r. Yes? Now, I'm hoping at this point here you're awesome and you know that once per anything, what doesn't matter what it is neither here nor there. Yes? So this can be 752,
Yeah,
it can be 16, it can be anything. It doesn't matter what this is because that's not going to affect the value of it. Yes? Still 1. So we can extend it.
Oh, that.
Extend it. Now we know that when we've got our power of 2, that's what we're looking for, yes? So we're looking for the term that has a power of 2. So we say to ourselves, like, which of these parts are we interested in? Well, we're looking at this part here, yes? So we know that n minus r has to equal 2.
That's what I got a mark for.
Yeah, I think that's why. Right. Several people did.
Yeah.
And then it's on.
I don't even know where this mark came from.
So we know that n minus r is 2. We also know, therefore, that r would be n minus 2 from that. Rearranging. Yeah?
Oh.
Really not
I don't
sure.
know why I'm not seeing this.
Really? Add r to both sides. I've just switched the order. Is that what's confused you? Oh, please tell me.
Okay, wait.
I don't mean to be rude. But
No, I just.
sorry, that's a naughty teacher. Are we alright with that? Are you really peer pressure?
No, I can see it. I was just trying. Yeah.
Alright, okay, so what that means is we can change this to be n and n minus 2. And then we've got 3x squared.
Wait, why is it squared?
Because we knew that n minus r has to be 2. Because they want the power, they want with the term with x squared.
Yeah.
Oh, you know. Yes, even
Yeah.
something they want, yes.
Okay.
Should we see that? Yes?
Yeah.
Now, lots of people are like, well, hang on, whoa, hold your horses. We don't know what this value here is. Okay? However, we do know we've got this. Well, how does that help us? Okay? Now, n factorial means n multiplied by n minus 1, multiplied by n minus 2, multiplied by n minus 3, etc., etc. Yes? I could go on forever and ever on it. Yes? This here, r, we know is n minus 2. So that would be n minus 2 multiplied by n minus 3 multiplied by n minus 4, so on and so on. Yes?
Why did you go up? So sorry.
We're taken away.
I'm
Yes?
sorry.
And then n minus r, we knew was 2. Okay? So this bit would be 2 factorial, which is just 2 times 1. Can I write 2 times 1? So that's that bit. And then this is 2 times 1. Because n minus r is 2
Okay.
from here. Okay?
What,
Okay. Okay.
Yes?
Yeah. Wait, can we take a
Wait,
text
my
later?
brain
I'll
is
take a
not.
list for a minute. Alright, stop whinging. Right, now, n minus 2, n minus 3. This is going to keep going, isn't it? Yes? And look, we've got a matchy situation going on here. So that all of these bad boys are going to go.
Okay.
Yes? Do you remember how we did that when we were talking about the thingies?
Yes.
So secretly, all we've got left here is n minus 1 over 2.
And okay. No,
Yeah.
I'm seeing it.
So this bit here is n squared minus n over 2. I've expanded it. Rascal. So this bit here, we just worked out here, is that expression.
Oh.
And then we've got 3x all squared, so that's going to be 9x squared.
Okay, wait. Oh, I see.
So that's that bit.
Oh.
And so now we know that 9 lots of n squared minus n over 2 is equal to 135n.
But what happened to the
Wait
n on top
a
of the n
second.
squared?
No, that whole thing is n minus n. That whole thing is different.
This was this,
Oh.
which ended up as this.
Okay.
So where's that n squared? I was making a face. Wait.
So my x squared's gone because they said that the coefficient of x squared was 135n.
Oh.
So I don't need to include him anymore because I didn't include my x squared.
So now you just multiply.
So now you're just going to have
Welcome back. Okay, the perfect timing.
I'm so bad. She's still aggressive. We haven't done anything wrong.
And then you get this bad boy. Yes?
No.
Wait. Hold the horse. Hold the horse.
Wait. Why did we get rid of the x squared?
Because they told us that the coefficient was, was x.
Oh, you
was,
times it by 2.
this was the coefficient of x squared. So I don't need to compare the x squared.
But just
like the coefficient.
The number next to it.
It says the coefficient of this was this.
Yeah.
So we don't need to include him anymore. We don't need to include the x squared. Because we're just saying that
How
this
is it?
is equal to this.
Man, you say so.
Because what's the coefficient of this? Is all of this stuff, isn't it? So that is what's equal to that. Oh, now
He just was talking about onion.
Alright, so we've got this bad boy. What kind of expression is this?
Quadratic.
Quadratic, Christian. So we've got 9n squared, and we've got 270 and then 9, so that's minus 279. Yes?
Yes.
So we can divide everything by 9n.
This is 7 marks. This makes me like 15.
Yeah, it's only 7. So that leaves us n minus, what's 9 times this? 31.
Wait,
Let's just take a second.
Just here, look, 9 into 279. 9 into 27 goes 3, 9 is 9.
This was a...
this class makes me feel incompetent.
Oh, don't say that.
Can't even address
wow.
Nothing
Oh, wow.
Yeah.
Because we had 25 minutes of chatting about it.
Oh, wow.
No
one needs to do that.
You're really complicated.